Ethan, why are you holding a cup of noodles?
Because I thought we were learning about nodal analysis.
No, silly, we're learning about nodal analysis. In brief, KCL states that the algebraic sum of the currents entering and leaving a junction of a network is zero. Whilst Ohm's law is a fundamental law that relates to voltage, current, and resistance within a circuit. When using When utilizing nodal analysis to solve for the unknown voltages, there is a general procedure to follow shown here. Step 1. Determine the number of nodes within the network. Step 2. Pick a reference node and label each remaining node with a subscripted value of voltage, V1, V2, and so on. Step 3. Label current directions and polarities. Step 4. Apply Kirchhoff's current law at each node except the reference node. Step 5. Solve the resulting equations for nodal voltages and currents. Now let's try an example. If you recall correctly, the first step is to determine the amount of nodes within a circuit. In this circuit we have one node here and the reference node down here. Step 2 is to pick a reference node. It isn't necessary, although we make it a policy to make our ground a reference node and assign it a potential value of 0 volts. 0 volts, and this we will assign V1. Step 3, we have to label the current directions and polarities. Let's say the current travels downwards here, therefore this will be positive value, as well as this resistor will be also positive to negative. The fourth step is to apply Kirchhoff's current law. The KCL at node 1, 2A equals I1 plus I2. In general terms, negative I1 minus I2 plus 2 equals 0. Solving, we have V1 minus 12, which is the input voltage, divided by the resistor where it is exiting from. Where we have I2, we have V1 minus 0 volts, because it is the reference node, divided by the resistor where it is exiting from. If we apply Kirchhoff's current law, we have I1 plus I2 equals 2. Solving this equation, using simultaneous equations or matrices, we obtain the value of V1 at 15.56 volts. As we have previously used set 4 and 5 to obtain the value of V1, we can use this value of V1 to obtain values of I1 and I2. If we do so, we substitute them into the equation and obtain a value of 0.44 amps for I1 and 1.56 amps for I2. If we substitute these values to confirm Kirchhoff's current law, we obtain a value of 2A, which is the overall current in the circuit, confirming Kirchhoff's current law.